Some of you would be new, and all of you who are new, please listen to the oocytes and embryos as what is given in the uterus and fallopian tube. Eyes open. Forget whatever you have learned before in your life. Erase it. Take a duster and erase it. Air we are breathing, it follows Henry's law. Henry's law. It means that there is a partial pressure of chemistry, of the basic chemistry of the body, how it works. In the body, we are using that we have to maintain the carbon dioxide levels to some point. In case we don't have appropriate amount of the carbon dioxide levels, in that case, or the carbon dioxide evaporates by if you open the door of the, and it may even take 30 minutes for it to recover after we close the door. So can someone tell me what will happen to the pH of the Henry's law? So if you get time to read about this, it's a pretty complex equations, but it's going to help you. The effect of the pH on the embryo. I'm wondering myself who is entering into the group now. So this is what we have to understand. This formula, as you rightly brought out, this is the right formula. Gas phase and pH. There are few terms I want you to get introduced to, some new terms. That's called PHI. PHI, I've already told you, PHI is a pH inside the embryo. That's an important critical metabolic pathway for embryos to grow. And then we have PHI outside. That is called extracellular PHE. And it is generally higher than PHI, but is known to be a critical factor in establishing the PHI. Obviously, culture media will have PHE. This is the culture media. Culture media will have PHE and embryo will have PHI. This will maintain PHE will maintain PHI. And what we measure is PHE and not PHI, because we can't measure the pH inside an embryo. Anybody can measure our pH by taking an acid-base ABG analysis. But of an embryo, we can't do a biopsy. We can't take out follicular fluid. So PHE we record, and PHE tells us about PHI. This is what you have to understand. But in case you have to know exact, we have to go for PHI. So how is the stage-specific pH achieved in the culture media? This we have to know. So we have told you stage-specific, it all depends upon the percentage of carbon dioxide in the incubator and also the door opening. More the number of the pressure of, we'll have 6% carbon dioxide and we have around 1 bar pressure of the gas. This will maintain the pH of 7.2. This we already know, but also remember that it all depends upon how many times you keep opening the almirah. Incubator is an almirah. In case you open it, the gas pressure which is coming from behind gas will come out under pressure, it will leak, and then what will enter is the laboratory air. And how much laboratory air, can someone tell me how much is the laboratory air partial pressure of carbon dioxide? Anybody?
0.03.
Fantastic. Henry's law, 0.03. So we have to always maintain the CO2 levels at 6%, do minimal door openings, and use a culture media, which is very steady culture media, and which has got a very known buffer formulation, which will maintain the desired pH at a fixed CO2 level. So why do we buy? I keep telling, I had a very interesting chat. I think Dr. Saab will be in the group. I don't remember her name. I said, name a thing which our country makes, which other countries cannot make. I think Sandhya was in the class that day in Delhi when we had this class. So anything which make in our country which nobody else can make. So the answer was, we could only come to one answer, that is Kanchivaram sarees. Sarees nobody can beat, but otherwise we have not, we can't even doing one of the largest number of IVFs in the world, India. We still can't make our own media. Media, nil. Anything in IVF which is required is nil. We don't even have our guidelines clear after 20 years of other countries coming with their guidelines. So now, but things are changing. They're in safe hands in big societies and Foxy. They're going to do a good job, I'm sure. With IFS, SR, and Foxy coming up, things will improve. That's a state. So embryo sensitivity to the temperature is an important aspect. Oocytes are more sensitive. I've told you already. Oocytes are more sensitive to pHe, pHi change. They are more sensitive to humidity and they are more sensitive to temperature. Clear? Blastocysts are more steady. I've told you already and you've understood. It's good to have 135 people back. And to all of you, I apologize again. This was beyond my control. I just couldn't remove those people. Sorry for the inconvenience. So when we develop stress for any embryo, with change of pH, temperature, or humidity, what will happen? We'll have spindle depolymerization and we'll lose an embryo or an egg. So what happens? Immediately the spindles will go bad. And in case people ask me what all blunders I have done in my life, I keep telling in the classes about my blunders in OPUs and ETs. But one big blunder which I never forget is it happened with me 2 times. Twice I've done this blunder, big blunder I've done, that all the incubators have got a tray which you keep inside, which is full of water. And we have to keep looking at the level of water in that tray. Twice I found that my technician didn't check the humidity properly and the tray was dry and we had a poor quality embryo. So we have to just remember that this blunder of mine should not be repeated by any one of you. When you have a tray, keep checking that tray and see that there is no water is adequate in that tray. Because all these incubators may not show you the humidity. They show you tray water levels. So you got to be careful about this. So just keep it in mind that humidity has to be checked again and again. This has happened to the best of embryologists. They have lost their embryos due to this, due to lack of humidity. You don't even realize it. Altitude is important for any one of you who are at high altitude. There may be some doctors from Srinagar here today. They're always there. Or 6% is the CO2 concentration at sea level. So in case you go to higher altitude, that's the time when the partial pressure of carbon dioxide in the air will fall down. The partial pressure of oxygen will fall down because we're going to higher altitude. That's the time we have to fill in. We have to fill in more carbon dioxide from the tank. So initially we are working at 1 bar pressure, which is giving us 6% carbon dioxide. Now we still may work at 6%, 1 bar pressure, but we have to increase the CO2 concentration. In the settings, we have to change and make it high by 0.6% for every 1 kilometer. This is one take-home message. Any one of you who's from north part of the country, they should know this. Fine. So as you see, we are at sea level. We are happy at sea level is 0 level. So sea level is 0 level, obviously. And here we are okay with 6% carbon dioxide. But as you go high, the carbon dioxide concentration has to go high as per the kilometers. How many meters we are going up. So it will become 6.6 at 1 kilometer. Okay, this is some take-home message I want to give to you. So we have just said, as we move to increase altitudes, increase the carbon dioxide inflow inside the incubator. I'm sure there's nothing much in it. You understand this, and this should be done. As a lab directors, many times you don't know this, and embryologists are traveling. They come from different parts of the country and they work in your laboratory. They won't know, and then we are at loss. This you have to know. This again, similar diagram I want to show you. I want to drill certain messages home as we do it in the classes all the time. That increase altitude means we have to increase the PCO2 content, partial pressure of carbon dioxide we have to increase. This you have to.
So this will increase the pH, decrease the pH also.
Yeah, but no, Ashwina, no. To maintain, I'll tell you, to at 0 level. Here, when you're here, you are in Lucknow, you are here, you are at actually 0. Here you need carbon dioxide to maintain the CO pH of 7. Rough one number I'm taking. As you go higher, we have to keep increasing the percentage of carbon dioxide at say 1 kilometer. It is, you have to raise by around 0.6%. Now your setting will be, here your setting was 6%. At 1 kilometer, it will become 6.6%. These are few Guru mantras I'm giving it to you. Isko, in case you have a dhaga or you have your headphone, what do you call them? The earphones, it may just tie a knot and keep it with you. You'll never forget.
Thank you, sir.
These things are not given in the books. They are given, but we're not able to understand them. So I brought in few concepts for you people here. Temperature is, we've spoken about CO2 and pH. I will kill it now. Coming to temperature, temperature is important. When temperature goes high or temperature goes low, the embryos can get stressed. So they need temperature of 37 degrees centigrade. About this we talk in the classes at great length. So remember that when you open the door of the incubator, the hot air will come out, CO2 will come out, CO2 will fall down, alkalosis, and the temperature, hot air coming down and cold air rushing in. You understand, no? Steam will evaporate always. So when you open an incubator, what happens? Hot air will try to flow out. When hot air flows out, the cold air will be sucked in. And the temperature is going to fall down of an incubator. So incubator opening should not be done. Just remember that. As far as possible, no opening should be more than 10 seconds. And 10 seconds, you remember the formula of 10 seconds or 20 seconds, we have had meditation many times. I tell you to close your eyes and think in your mind, what are 10 seconds? Incubator is not like our almirah at home, in which we keep putting in our clothes and we don't know what we are keeping it there. So when our children are small, we buy a small sweater for them. And when they are getting married and they have their own children, we show their children the clothes of our children when they were young.
Cluttering.
So clean your almirahs. Friend, clean your almirahs. Don't keep your clothes of your children to be given to your children's children. That's clutter. And same thing happens in the incubator. In the incubator, in case you keep multiple plates, you don't know where you have kept things. I've seen people, they open the incubator and they're looking inside like this. Kahan par hai? Where have kept that plate? They'll keep shifting plates. That's not the way. When you work on an incubator, it's a 160-liter incubator. The moment you open your hand, you open, hand goes, take out the embryos out, 5 seconds, closed. You shouldn't go inside and dhakkan. They pick up the dhakkan, they look at the plates, they try to find out. That's a wrong method. That should not happen. So the repeated openings may cause cumulative lowering of the temperature and the CO2. This is important. Strict temperature and monitoring and control is advisable. And similar precautions and concern about the CO2 levels and humidity I've already covered for you. The loss of humidity will occur when we open the incubator and hot humid air comes out. Can someone tell me the humidity in the IVF lab?
40 to 50%.
50%.
40,
Incubator?
more than 90.
95.
90%. Can someone tell me the class of air in the lab? Shipra, Shrivastava,
Class 10,000.
Class 10,000.
10,000. ISO 7.
Someone let me remove.
So you're not audible.
I'm saying Shipra Srivastava is writing on the screen. Shipra, are you writing? And are you a non-hacker? Please don't do it. Hacker side we can't hold now. What names they come? So just remember that when we talk about the class in the lab, the class of air is class
1,000.
7.
10,000.
Class 7, 10,000.
Seven.
And the class of air in the incubator is class 5.
Class 5.
Remember this. So we have to, when we open the incubator door, hot air comes out, the temperature will fall down, alkalosis will occur, humidity will fall down, but again one more thing will occur, that dirty air will go inside. This has to work at class ISO 5. Just how incubators are worked, and air which goes inside is ISO 7. So incubators can become contaminated. This is what I want to tell you here. And just give me 1 sec to remove Shipra's drawings from my screen. Yeah. So temperature control outside the incubator is also important. That just remember that we have to maintain the temperature outside also. And in case the temperature is not maintained outside, the incubator can become cooler. Time of temperature recovery after a single 5-second door opening can be 20 minutes. Once you open the incubator door, it can lead to temperature loss, and for coming back, it may even take 20 minutes. Huge issue. That's the reason we are now moving away from box incubators. Look at a single door opening of 5 seconds. If the door has been opened, it takes around 20 minutes or 30 minutes for it to become stable again. One door opening, short as a door opening, can lead to so many problems. So door opening should not be done. The use of pre-mixed gases. Here I'll tell you that initially we were using 6% CO2 and it had 20% oxygen. Then we have shifted to mixed gases now. Tri-gas, about which we have spoken in the class multiple number of times. It has CO2 of 6%, O2 of 5%, and balance of nitrogen. Called tri-gas. And tri-gases are available in the market easily. But only issue with the tri-gases is that they're not available in tier B cities. They're not available in tier B cities. So tri-gas, this is the problem. It is difficult to measure. We can record 6% CO2, we can check by a device, analyzer. But there are no devices to check or no ports available to check this gas mixture in the incubators. They are not all that advanced. Nowadays, we have gone to low oxygen culture. And why we have gone to low oxygen culture, I've told you already, that in the body, we inhale 20% oxygen. In the body, by the time it reaches the tubes and uterus, it becomes 5 to 8%. So in case we have higher oxygen concentration, we can have these many problems. This is the challenge which we are. So we are trying to work at a low oxygen concentrations, and they found that lower oxygen levels are good for us, and they will help us in having better outcome and a better embryo development rate. So for blast culture, low oxygen is a must nowadays. So this is important, and data shows a clear benefit of low oxygen concentration for culture media for day 6. So nowadays we are working at 5% oxygen. So to work at 5% oxygen, the way we have it, if we got a tri-gas incubators, which gives us 5% oxygen, pre-mixed gas cylinders we get 6%. It's got 5% oxygen, 6% CO2, and balance of this comes in a cylinder, packed cylinder. Number of incubators in the laboratory, how many should we use? So normally incubator, which is around 150 liters, which is working on 6% carbon dioxide, we don't use more than 4 patients per incubator. Not more than 4 patients per incubator. And nowadays we are going towards the level of 1 patient per incubator. But these are incubators are costing around rupees 6 lakhs. Incubators they have kept here. Just they're tri-gas incubators. See, so many of them they have kept. These are the CO2 incubators. So better the lab, more the number of incubators they will be having. How to measure CO2 in humid incubators? Now, these incubators can be with humidification, and the newer incubators are non-humid, without water. Nowadays, we are working towards non-humid incubators because non-humid incubators, whenever we have humidity, humidity means more maintenance, and humidity means more infection. These two things are important. So we have to look at these two things as we are working. So nowadays we are moving towards non-humid incubators. Remember that. And I'm going to talk about that. So sensors in the incubators. How many sensors, types of sensors are in the incubator? We have a sensor for temperature. We have a sensor for CO2. We have sensor for oxygen. I won't go into the details due to paucity of time now because class was also hacked for some time. But we need a temperature sensor in the incubator which will tell us 37 degrees centigrade, carbon dioxide 6%, and then we can also have oxygen sensors in the incubator. Normally, we don't have any nitrogen sensors. We don't use them. So temperature control, once we look at it, we have to maintain at 37 degrees centigrade. Less than 37 or more than 37 can lead to DNA spindle damage, which we have covered. So what type of sensors we use? You'll find that these sensors are temperature sensors. They're of two types. I'm not going into details here because this is meant for our own classes which we take. There we talk in details. We have LM35 and we have PT1000 sensors. Just remember that they can maintain temperature between -55 to 150. These are the temperature probes and they are part of the incubators. LM35. So when you buy an incubator, look at good ones are coming with PT. They come with PT1000 temperature sensor. This is only to educate you. PT stands for platinum. Just remember this. PT stands for platinum. We'll cover them in our classes when we have our batches. But here I'm just giving you an overall view. Then we have got a thermal conductivity TC scanners. They are older generation scanner, older generation sensors, older generation. Avoid buying incubators for such TC sensors. They're older generation. They're good, but they are older generation. We don't want to buy sensors with the thermal conductivity sensors nowadays because they are older variety. Nowadays, we are moving towards the CO2 sensors are something like M400 or NDIR sensors. They're called non-dispersive IR sensors. So nowadays they are around 1 lakh expensive approximately, and they last for around 3 years. Then they go bad. So IR sensors are important for us. Buy an IR sensor. Now, this is a basic infrared sensor. It basically works that the CO2 gas is absorbed at the wavelength of 4.3 micrometer. Let's remember this number. So they look at the absorbance of the CO2 at the wavelength of 4.3 micrometer. So then there's a IR detection here and IR processing here. There are interference filters and there's a bulb placed here. So bulb will give you 4.3 micrometer ka light. So now it is an IR light source. So it's a dual detection IR sensor. They are putting dual IR detectors here to make it better outcome. So light is burning here. And nowadays we have got better sensors. As you see here, we have got a mirror surface from which the light is being thrown and the gas is checked here and we get the change, and basically it works at 4.3 micrometer light. Just remember that. The newer, now we are shifting from the regular bulb to silicon IR light source. Just remember that. This is a new thing which has come. and it's got an IR sensor with a reference sensors. So they are actually dual IR sensors. So this is a new terminology. Just remember that this is the way the things work. Here, I'm not going to go into big details because this is beyond the preview of this class. But now we are moving to silicon light chip. This is important. Then we have got a CO2 sensor, O2 sensors also we have, and they are K25. They are K25 O2 sensors, and they are put in all the new incubators now. This is important. And they are along, so we have CO2, we have temperature, we have oxygen sensors in the incubators nowadays. These are the older incubators. We had a box incubators initially, which we were using. They can be water or air jacketed, and they are 150 liter approximately. So these you require 2 per lab. When you want to start a lab, and say you want to do around 20 cases a month, buy 2 of them and buy 1 benchtop incubator. These 2 lab incubators should be 150 liters approximately. And they should always prefer to have IR sensor and stainless steel chambers. Now we are getting copper chambers, which are much better. But these are the ones we use zirconium oxygen sensors. We use temperature sensors, which are platinum. I've told you PT, platinum. But now these sensors, these ones we are not using for embryo culture. These basically we are using them for media equilibration. Or other gases pH in less than 1 to 3 minutes. Here it took around 30 minutes. And here it is 1 to 3 minutes. So you see this beauty of this technology. And they have got a pre-mixed gas, triple gas, or they use a gas mixer. These can be humidified or they can be non-humidified. So quickly I'll take you through this. These are a few technologies about which you're going to speak, and I will go to not theory, how to choose the best incubator. It depends upon how much money you have, how much space you have. But remember, in case you want to set up any lab, we need 6% CO2 incubator. We need 2, 1 for the lab, IVF lab, and one for the IVF embryology lab. So buy 2 of them and buy 1 benchtop. These 2 we have to buy. Benchtop can be humidified or non-humidified. Now box incubators are 6%. That's the way they work. Because you buy them, you can see that they can give you the CO2 and temperature. When you open them, when you open the doors, they lose the temperature, humidity, pH, CO2. So door opening reduces temperature and everything in the incubator. The door opening should be avoided, and it can lead to 20 minutes time for recovery after 5 seconds. This I've covered. That's how we keep the plates here. They normally have 3 compartments, 3 stainless steel compartments. And when you buy them, you should have 3 separate doors. Don't buy a single door, buy the one with 3 doors. Flatbed incubators, the newer ones, how they work. Then there was a tri-gas. Okay, coming to flatbed incubators, how they work, they are normally dry incubators. They don't have any water. So how do they work? They take carbon dioxide from a cylinder at 1 bar. They take N2 at 1 bar. Oxygen from the atmosphere. They have a gas mixer here. Gas will take the balance of gases from the room, filter them. It goes to incubation chamber, and then it is UV sterilized and the gas is recirculated. That's the way these incubators work. This is one of the examples, and as you can see here, that we have got 10 chambers here. We have 1, 2, 3, 4. We have got 10 chambers here. 1, 2, 3, 4. So every chamber is for 1 patient. This is how these plates they work. We have kept our plates here. They've got a heated top and they've got heated bottom. They recover within less than 1 minute. And 1 patient per incubator. This is how they work. We keep our plates here. And I showed you in a 6% CO2, we keep them here like this. And here we keep it like this. So these are the chambers and the multiple, there are, this is again, I'm not talking about any company here. These are plates on which we can keep a 60 ml plate, or we can keep the Falcon dish here, a 60 ml plate, 30 ml. So these are the inserts which go into these. These are the inserts which we have. These are called the inserts, and they can be changed depending on what type of plates you want to use. And these all plates are available for different companies. So these plates are available. Some of these plates, higher incubators, have got a small hole. And this is for the measuring the pH. So they will go below and they'll go to the pH meter. This is how they work. Quickly, so these incubators can be with humidity or they can be dry ones. Nowadays, we are going on dry incubators. My preference is dry incubators, where we don't use any humidification. So this is what we have to know. And these are the incubators which work without any gas, any water content in the air. Here we use a thick layer of oil. That's all we do. Older dry gas incubators, which you are still using. So the bigger incubators like this, they all cost around around 16 lakh rupees. Box incubators, they cost us around 6 lakh rupees. And these dry gas incubators, small ones, they all cost around 5 to 6 lakh rupees. They've got two chambers here, and they normally give you temperature and humidity. You got humidification flask put here down below. So they take dry gas here, which is a mixed gas with 6% CO2, 5% O2, and balance of nitrogen. So they come with a cylinder from below, and we normally work at 1 bar positive pressure. This is how you can keep 4 patients keep plates here on average. But they're actually meant for single patient. But we can do 4 patients easily in this. But once you open it, then the temperature and gas will be lost very quickly. So in case we keep these incubators where we keep only 1 patient per chamber, we have better control. So that's the main disadvantage, but they come cheaper and they give you the chamber 1, chamber 2, temperature is shown here. And they are dry gas incubators and they work with on humidification. This is my favorite bench of incubator called Mink. So here you can see the humidification flask, which is giving humidity to the chambers, and you can do 4 patients. But normally I don't put more than 2 patients, 2 here and 2 here. That's all I do. So they are called dry gas incubators. So this is the closer view of a dry gas incubator. Nowadays incubators they occupy a lot of space. So what we do is that we do stacking of them. So we can keep stacking our incubators one upon another. They're called stacking and drawer incubators. So whenever you look at this incubator. This incubator will take around nearly 1 meter of space. They're so big. So in case you keep in the lab, they will take around 1 meter, 1 meter, 1 meter. Labs are small. So what we do is that we stack them over. So we got almirahs like this. We can stack 3 to 4 incubators in one almirah. So they go vertically stacking. Box versus benchtop incubator. I've told you that benchtop is any day better. And benchtop, non-humidified is better. So nowadays they're going to flatbed benchtop incubators. Always buy 2 6% box incubators, or you can buy 1 to start with, but 2 are ideal, 1 for IVF, 1 for embryology, and buy 1 benchtop incubator, depending upon how much work you have. Benchtop, simple one with the dry gas will cost you around 6 lakhs. This is humidified. But in case we want to expand, do a lot of work tomorrow, then you should buy one with the 10 or 12 chambers. This benchtop is with 2 chambers. So buy one with 10 to 12 chambers and buy dry with mixer. In mixer, we don't use dry gas. We just put a cylinder. So the main difference is that in these incubators, what I'm showing here, we use a mixed gas, dry gas. But when we use these incubators, the bigger ones, here we don't use mixed gas. So there are 10 chambers per patient, as I told you, 10. So we use pure CO2 and N2, 100%. CO2 and N2, 100%, and this is the way they work. You'll find that we'll keep 2 cylinders here. One cylinder will be of N2 and other cylinder will be of CO2. And it's got a small mixture inside. So gases will take whatever it wants and take oxygen from the air, as I've shown you here. So it takes oxygen from the air. It's got a mixer in it. So they all cost around 14 to 15 lakh rupees. And so we should always, for a beginner, you can have one box incubator and one bench top incubator. But I'll say that minimum 2 incubators you should take, box type. Time lapse is one thing which I'm not going to touch. Time lapse I'm not talking here because it's not required. We cover it in our classes. So with this I end my talk here. And I'm sorry for all the chaos which occurred today, but we enjoyed the journey. I'm sure we enjoyed this hacking, or deliberate or accidental. We enjoyed it. And the next class is on fertility preservation basics. And then after that, we'll have a class on semen analysis 6th edition when the time goes. So I'm sure that you would have already downloaded this bulletin from LinkedIn. And it's a pretty large number of hits. We have got more than 1200 downloads of this bulletin. And this one, Chlamydia and Infertility, written by Gunjan and edited by Akriti, is a real good one today, which has come. You can download it. And just as a sum it up, as I like to say that we can always find dirt in anyone, but try to look at gold. Just be happy, have trust on people. And I think that's it from my side today. And let us pardon the people who have tried to hack our program. With even that, we are touching a number of around 135, 140. And that's it from my side. I've ended my talk. I'll take few queries in case you have, and rest otherwise we'll discuss in the class itself. I'm open for 1 or 2 queries. In case I go to chat box, I'll take some questions in the chat box. You can please put on your camera and say hello. You have been with us and creating new links. So thank you so much, Sandhya, and thank you so much, Ashna, for getting me back here. Okay, so there is one question.
Sir, for embryology, we need incubator.
Yeah, for embryology, Sushma, we have to prepare the semen sample. So the semen sample, please switch off everyone. For embryology also, we need the incubator for equilibrating the media. For this, when we do this swim-up, it has to go on the CO2 incubator, no? The swim-up incubator. So we shouldn't use the one we need for media equilibration and one we need for swim-up for embryology. Sperms should not come in the incubator in which we are keeping our culture media. They should be 2 different ones. Many people use one. Up to them. If you can afford, it's a matter of 5 lakh rupees, but the results are better. Then, how is osmolarity maintained in dry incubators? Osmolarity is maintained because we use a big, thick layer of oil. That's it. So oil won't allow the media to evaporate. Fine. So I think there are no more queries here. Yes.
Can you talk about the frequency of water change, filter?
Very important. I've told you that this is my blunder in life. I remember two instances where I was careless. I've been doing embryology from now 20 years, but I made a mistake. Twice when incubator was dry and we lost a lot of embryos. We got poor quality growth. So I always say on an incubator, put a small parchi. In that parchi you write, daily we are checking the CO2 and temperature. Humidity we are checking every day. But on parchi you write 2 things. When do you want to change the inline filter? Inline filter we have seen in the class many times. Inline filter should be changed every 3 months. So in case you put an inline filter today, you write next change is in, say, May or June. February, March, April, May में change करना है. So उसमें write very boldly on a piece of paper, June में replacement or May में replacement. Then for water we normally top up every week. Every week we have to top up the water. Never. So make a policy that every Monday when you go, open and look at the water. Never allow the water to come down to less than 50% of the requirement. Otherwise, you may forget. So that's the way. Every Monday I replace water. So this is about the water change. And one more thing, since you're bringing out QA, QC, never stack your box incubators on the ground. Because never keep incubators anywhere near 3 to 4 feet from the ground. Because in case you open the incubator, the dirt from the ground will go inside the incubator. So always keep the incubators around 3 to 4 feet above the ground. This is what you have to know. Use anything which has got hypochlorous ions or quaternary ammonium compounds. They are incubator cleaning media that are available. Incubator meaning cleaning centers that are available from companies like Origio, SAR or Cook. 𝙀𝙤𝙧𝙟𝙤𝙪 is my favorite. Use that to clean. And then they don't generate many VOCs. You can use them. But in case your incubator, normally I like to clean my incubators every 2 months. 2 or 3 months, we do a lot of work. So every 2 or 3 months, we shut it down and clean the incubator and put it on sterilization mode. So they can have different type of sterilization techniques. Some incubators, they go till 180 degrees centigrade, then maintain at 4 hours. Some work at 120 degrees centigrade. So that's depending upon what type of company's incubator you're buying. Some going for deep sterilization, some going for smaller sterilization cycles. So that is the company will tell you. But every 3 months, I think we should shut it down and clean the incubator. The smaller incubators, the bachelor of incubators are not, they don't need any maintenance. So there are 10 chambers or 12 chambers. So any chamber which you're not using, take some 𝙀𝙧𝙬𝙀 and clean it. That's it. Bigger incubators, 2 to 3 months you have to clean them. Use some sprays. Their sprays are available. You can use them. Use some distilled water to wipe it off. Remember, for everybody who's here, remember one more dhaga I'm giving it to you, which you can tie on your things. Companies may tell you to take purest quality of water for incubator. Never take triple distillate or pentadistillate water for an incubator, because those waters are very high quality. When you use a very high quality water, that will leach away the ions from your stainless steel. So you have to use a distilled water, which is meant for your incubator. That's a class 2 water. Don't try to put in a class 1 water. That is not a class 2 water. Is good enough for your laboratory. Don't go in for pentadistillate and high class waters, because they are totally electrolyte free. And when that water is totally electrolyte free with high number of ohms or resistance, they will go inside your incubator stainless steel and take out the ions from them, leach out. So you should be very careful about what water you use when the incubators. And I think that call you will learn when you start doing the works yourself. So there are some waters available for incubator grade by those waters only. Don't go in for the highest quality of waters. That is not required for incubators. One last question I will take. I've got to go to my OPD.
Assalamu alaikum, sir.
Thank you, sir.
Sir, about the water, sir. Sir, we buy milky water. That's okay, sir, for incubator?
Milky water has got many qualities. Milky water can be multiple distillates. You see, I will, in case you want, I'll try to give you the quality of water.
Sir.
You have to buy water from a good company which is meant for incubators. Ask the company. Milky waters of a high class pentadistillate water, that is for chromatography, for making culture media. In case I want to make culture media like this, I use that type of water. That water can't go in the incubator, because incubator stainless steel will go bad. So that can be discussed offline. But just remember that ask the company, is it water okay for my incubators or not? Read their literature. Don't try to buy the top quality water. Top quality water is not meant for incubators. Only.
Sir, I understand, sir. Sir, what the problem here, sir? I do not get what you say. Everything is not available here, sir. So we go for a distilled water plant, sir.
I'll tell you what to do. I'll tell you. Give me a call later. I will tell you what to do.
Sir, I need his guidance, sir.
Yeah, I'll let you. There are companies which will supply to you. See, I don't want to take companies' names here in the open forum, but you can. I'll tell you who will give it that.
Sir,
They're
I
supplying
need
water.
the specification of the water, sir. So that I.
WhatsApp me. I'll tell you.
Okay, sir.
I don't want to talk about companies here, but
Okay.
they're all supplying in Bangladesh. It'll be done.
Thank you, sir.
So I think we'll end here. And
Sir, if the lab humidity is high, then what should we do?
humidity.
Lab humidity is high.
Nina, we have to keep. Can you put on the camera, please? Everyone who's talking, let's see, say hi to each other. The overall, you have to maintain the humidity to be 50%, Dr. Nina. That we have to maintain.
Now, sir, suppose it is high.
You have to
Suppose
reduce
it is
it.
60%. Sometimes it is raining outside.
Then you have to ensure that your humidity is low. Then you have to put on some heater.
Okay.
You can't have humidity of more than 50% because in case you have such high humidity, it will cause bacterial spore contamination.
Okay.
That's the beauty. Are you part of our batches?
No,
You're
sir,
not part
I
of-
want
yeah,
to be.
That's the reason you're asking this. We
Yes,
discussed this at great length nowadays. Spend around 8 to 9 hours on this thing. So you have to. This is what the quality check is. You have to maintain your humidity.
So one last
Yes.
heater, and you're talking about heaters, of which now so many heaters, coil
No.
heaters. oil
I'm not saying
heaters.
any heaters. I'm just saying this. These are company will tell you. Whosoever is setting up the
Acha.
lab, they will tell you what to do. But I'm just saying in this setup that you need 50% humidity for your room, and you need 90% for your incubator. That's what I'm saying.
No, that's a separate. I mean, heater there because temperature is too low nowadays here in North India. So, which kind of heater you use normally for lab?
We don't use any heater for the lab. Never we use any heater for the lab. Then you have to
maintain?
buy an air conditioner, a heating cooling air conditioner.
Okay.
So heater हम use नहीं कर सकते ना. Heater will burn the laboratory. Heater will be very harmful for us. When I said a heater, I meant a heater in the AC plant. Yeah, Aditi, in our classes nowadays we are teaching what class of lab we have. Depending on what class we have to take a call. So in case we are not able to afford putting an HVAC, in that case you have to buy original ACs, OG ACs lagao, which is about heating and cooling.
Yeah.
This is what I meant. I'm sorry. This is what I meant.
No.
Heater nahi lagana kabhi. Heater we use only for burning in, not anything else.
And then camera.
Okay.
So guys, thank you so much for being with us, and most of all, when we had this hacking gone today, it was an experience for me. I could never understand how somebody could hack our program, but good thing, hacking is good for us. We learned, and thank you so much, my team, for getting the links very quickly, and thank you so much, all of you, for again rejoining and it's a large number. I hope that.
Dr. Pankaj, can I ask what is your
It is a wonderful class, sir.
Thank you, Sushma.
Thank you so much.
Thank you.
Thank you all. Thank you for
Have a
being
nice
with us.
But do download Chlamydia article, very nice one. Do download it.
Yes,
Thank you.
please just click on the link and go through that article and please give us feedback.
So we are writing our numbers here. In case somebody wants to contact us, we are writing the number. I've written my number here. You can copy our numbers here. That's it. So thank you so much for being with us. Have a wonderful day ahead. Bye. Take care.